Even a monster like a black hole is born from a mother like gravity. Inside a star, gravity pulls the hot plasma outward while nuclear fusion pushes it inward. This balance between gravity and fusion creates a stable star. But when this balance is broken, gravity wins. As the star collapses, matter is squeezed to unimaginable densities, creating a singularity. All the matter in the universe would weigh the same if it were squeezed to the size of a proton. Gravity becomes so intense around this singularity that not even light can escape, collapsing the star into a black hole. Only a tiny distortion in space-time remains, a cosmic monster ready to swallow anything that strays too close. Light takes time to travel. A photon can zip from one end of our galaxy to the other in about 2.5 minutes. But if you watched a rocket launch from Earth, you would see the fire and smoke trail behind it for another 4 minutes until light from those phenomena reached your eyes. In this sense, we always see the past. We see the universe as it was hundreds of thousands of years ago. It's the same with black holes. What we see now is the light that started traveling toward us long before we discovered black holes. But how do we know what they're really like? How do we study objects whose gravity is so strong that not even light can escape their grasp? You can't directly observe something that doesn't interact with light, and since black holes don't emit any light, we can only infer their presence indirectly by studying how they affect things that do emit light. For example, stars and gas clouds near black holes speed up as they spiral into them. By measuring these speeds, we can estimate the strength of a black hole's gravity. Astronomers have also detected gravitational waves, ripples in space-time itself, that are produced when massive objects accelerate, like when two black holes collide and merge into one. In addition, we can observe the effects of light passing close to a black hole. When light bends around an object, it acts like a lens, focusing the light from objects behind it. This is called gravitational lensing. These cosmic lenses can magnify and distort the images of galaxies that lie far behind black holes, allowing us to see them more clearly. X-rays and gamma rays produced by superheated matter around black holes also give us clues about their behavior. All these indirect observations allow us to piece together the story of how these cosmic monsters work. Most black holes are around 10 trillion kilometers in diameter, about the size of a solar system. Their gravity is so strong that not even light can escape, collapsing the star into a black hole. Only a tiny distortion in space-time remains, yet despite their gargantuan size, most black holes are invisible. They don't emit any light or other electromagnetic radiation that we can detect. Only when something ventures too close does it disappear forever beyond the surface of no return, known as the event horizon. If you were to fall into a black hole, you wouldn't even know it. You wouldn't get pulled apart by tidal forces like an astronaut inside a black hole, because nothing can escape from inside a black hole, not even the light you emit. There would be no one to observe this process. Your journey to the center of a black hole would be like stepping into another dimension where gravity abruptly stops pulling, and you can move freely in all directions. Once you cross the event horizon, time as you know it ends. You've entered a region where the laws of physics as we understand them simply don't apply. There's a lot we still don't know about black holes, but studying them helps us understand not just the origins of the universe, but the nature of gravity itself. Black holes are the key to understanding how the universe began. The Big Bang theory states that the universe began with a hot, dense singularity, much like the center of a black hole. By studying black holes, we hope to unravel the mysteries of the Big Bang and learn how the universe evolved into the cosmos we know today. So keep looking up at the night sky. You never know what secrets you might uncover.